My apologies. I paused the video for something and got kicked off, so we had to do video B. All right, so the formula for permutations. Let's look at what everything means, okay? And I know this may look weird, this little n, capital P, little r, but just hold with me here for just a minute and I'll explain all this. Also, beside this n, you're going to see what is an exclamation point, an exclamation mark. And we're going to have to talk about that because it may be new to some of you. This is n minus r, and it's lowercase r, all times this multiplication mark. Now, what we're looking at here is this is a permutation, okay? N is the number of objects selected, and the total number of objects, and R is the number we're going to select. So let's say that I have 5 kids running a race. All right? And I'm giving away trophies for 2 places. First and second. 2 places for trophies. Well, how would these numbers fit in there? First of all, N being the total number of objects, how many kids do I have running? 5. So this is 5 permutation. And how many places am I giving away? How many objects am I selecting? 2. So that's what it looks like. The permutation of 2 places being chosen out of 5. How many possible outcomes are there? Now, the number of objects is 5. R is 2. We got that. To do this, I'm looking at 5 factorial over n minus r, which is 5 minus 2 factorial. Well, side note, factorial. What that equals is like the factorial of 5 here. That's 5 times 4 times 3 times 2 times 1. And we're going to get into that some more as we go through this. In fact, I think I messed up. It was supposed to be on the next page in notes. So let me put it over there. What is this factorial? So 5 factorial is 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. We don't use 0 factorial because 0 factorial is equal to 1. So let's go back to this problem. You can do this by hand. We already said that 5 factorial is 120, so you get 120 divided by 5 minus 2 is 3. So 3 factorial is where you're at on the bottom, and that's 3 times 2 times 1. Well, 3 times 2 is 6, times 1 is still 6. 120 divided by 6 is 20. So there's 20 possible arrangements for first and second place with 5 kids running a race. Now, I want you to try this problem. Try to lay it out like I did this one about the race. See if you can come up with an answer and come back for a solution here. Okay, so I hope you came up with the same solution of 20. There's 20 possible photos that you'd have to pick from. Now, that was still 5 flavors of ice cream. The permutation of picking 2 different flavored scoops. 20 possible combinations there. All right, last but not least, combination. So I'm going to use combinations when order does not matter. Okay? I've still got this N and R in my formula with a C in the middle. That C stands for combinations. The formula for this is quite similar. Okay? You still take the number of objects, factorial, but this time you take the number of desired results, factorial, times the difference between the number of objects and the number of desired results, factorial. Okay, so let's look here. Suppose there are 12 employees in an office. The boss needs to select 4 of the employees to go on a business trip to California. Doesn't matter where he picks them in. He just can only pick 4. So in how many ways can she do this? Let's use this to find out. So, suppose there are 12 employees. Well, that's our N. That's the number we've got to choose from. What's our R? We want 4 of the 12. All right? So, 12 factorial. R factorial. 4 factorial times 12 minus 4 factorial. That's the denominator. We'll simplify one time here. What is 12 factorial divided by 4 factorial times 8 factorial? Now, I don't know what kind of calculator you're used to using. You can do this online. You can pull up the permutations and the combination calculator, or you can find one of these old-timey TI-30s, which I'm trying to get my hands on over here, and do this in there. It's actually a button on the calculator. Where's it at? This one's written all over, so of course I can't see it. So, hold on. And I'm back after hunting for a calculator. So, you're going to see in blue, right above this data thing, the word step. So you hit second step. And, hold on. So sorry, I don't know what I was thinking. It's a probability thing. Combinations and permutations are the probability, how many possible things you can get. So do you see this PRB? PRB stands for probability, okay? You hit that. Well, remember, this one is a combination because order does not matter, right? So you move over and pick the combination thing. And then it's going to ask you. Clear it out. We're going to do the combination of 12 and 4. 12 and 4. And maybe, I don't do these with a calculator. I might do that 12 factorial with a calculator, and I can show you that too. But 12 and 4, 12 is our N, so we put it in. Then hit probability, choose combination, okay? And 4 is our R. Then we hit enter. There's 495 possible combinations here when order does not matter. Now let me show you something else. If I put in 12, hit this probability button, go over and pick up that factorial and hit enter again. Look at that number. That would be the top of the problem. There's no sense in all that. Use the shortcuts. But if you don't want to, 479001600. That's the top number. Then down here, clear it all out and do 4 factorial times 8 factorial. Hit enter and you get this number, 967,680. Do the math on it. 479,001,600 divided by 967,680 equals 495. Okay, if you need help with this calculator, let me know. If you are using an online calculator, you better hunt for a permutations and combinations calculator. I know that several are online that do those functions. Good luck.